Let's look at simulations and see how they can help us answer questions like what is the probability of a forecast level being greater than some amount, or what's the probability of days between orders being between 1 and 2, or something like that. There's lots of questions that it can help answer. What it will do is provide a distribution of outputs, and then from that you can compute probabilities. So we're interested in determining the outputs of interest and setting bounds on them, and then creating a set of random numbers between those bounds, and using those as the inputs to create the outputs, and then creating a distribution of the outputs, which is the frequency function in Excel, and adding up the probabilities, and then maybe doing a data table. It's an interesting part of it there, and then we can graph those. So let's set up our upper and lower bounds. So I'll say this is the these are going to be my upper limits. Put my hands on the right keys, upper limits, and these will be my lower for each of these. So let's say the demand, I think, is going to vary between 200 and 400. And the standard deviation I'll use will vary between 50 and 100. And the number of standard deviations I'll use will vary between 2 and 3, and the lead time will vary between 1 and 3 days. So those are the limits that I will use. And the way I will use those is I will say rand between, say equals rand, this keyboard I'm not used to, rand between that and that. So I want a random number between those two. And in fact, I want to get random numbers for all these. So this is my daily demand and my standard deviation and confidence interval and lead time. And then from that, I can copy and paste this, and yea verily, I'm going to be using the right numbers to create these values that I'm interested in. And in this case, I'm really interested in the forecast level, but all these are possible outputs of interest that we could get distributions for and then probabilities for. Now what I want to do is take this and create many instances of it. And so I want to drag these down. Well, I need to change these to be absolute. All right, I've got all those correct. Now I can drag this down as many samples as I want. And so maybe I'm interested in about 100 of them. So I'll drag this down, and I should have kept track where I started. So there we go, and I've got a bunch of nums there, so somehow I messed this up. Oh, well, I thought I had that one set. I guess I did not. There. And now I can take this and double click, and I can double check some of these. Yeah, that looks right. So this is my distribution. Let's see how many I've got here. Shift, end, down. I have 99. So just to make things a little bit cleaner, I'll go ahead and make this 100. There. So there's all my data. So I've got my random numbers between the bounds. These are the inputs to create these outputs. Now I want a distribution of outputs. So I want to put these into bins. In this case, I'll look at forecast level. So I might be interested in the min and the max for these values that I've collected. So the min is the min of all these forecast levels. So there's my min and my max. So these are going to be the boundaries that I'll put on my frequency. So my forecast levels were somewhere between 700 and 2600, and so maybe I'll say I'll go between, what the heck, I'll start at 0 and go up in steps of 500. Now notice how every time I make a change that the random numbers are recalculated. So there's a pretty small frequency chart. So these are my bins. I'm going to put things in. Now I'm going to count the number that are in those bins, and then I can calculate probabilities associated with those bins, and then I can do some other things. I'll do a data table. So my count is this frequency, and all my data is all this data. So I'm doing shift end down, comma, and my bins, these are my bins. Then I have to do control shift enter, and that's the distribution. So there are, in this case, there were 5 between 3,000 and 2,500. There's 0 between 500 and 0. There's 15 between 500 and 1,000. So that's how you read this. This 15 is, there's 15 between 500 and 1,000. And we could graph this in a scatter chart or a column chart or whatever we're interested in. Here, I'll connect them, see how they look. So it looks kind of like that. You need to be careful. It's not gonna have a negative there. That's the smoothing effect that it provides. So it looks pretty normal. I think I'll just delete that. Now if I sum these up, then that's my count, which yea verily is 100, and then I can compute the probability, which is this divided by my count, and I'll just stick that down there. And so these are my probabilities. I might be interested in what's the probability that it's above 2,000 or less than 2,000. So if I say sum those, that's the probability that it's greater than 2,000. And the probability that's less than 2,000, well, I could just say it's equal to 1 minus this, or I could sum those up either way. So what I might be interested in doing is creating a table to see how sensitive this is to changes in this upper limit of the daily demand, or the lower limit, or different things like that. So a data table is going to create a range of values that I want to put into, let's say, the daily demand. I think it's going to go up. And so I'm interested in the changes from, let's say the daily demand goes from 200 to 300 to 400, and say it goes up to 600. So I'm just changing this one here. That's the only thing I'm changing. And I'm interested in what happens to this value, and I'm interested in what happens to this value. So I'll chart them together. They're kind of opposites of one another. So this is the data table, and this is how you create a data table. You select those values, and I've pointed them in, pointed at the right places, and I do what if analysis, data table, and the default is row, which means that these values are in a row. Well, these values aren't in a row, they're in a column. So I'm going to take this column of cells and put them into that cell. That's how you do these. And so that's the way it looks. So this is the sensitivity to changes in that upper limit, and the probability that you're going to need forecast levels greater than 2,000. So I just picked that number. I wasn't sure what was going to going to happen there. So if I graph this, let's see, I'll graph this as a line chart. So it looks sort of like that. And I should have labeled these, but I can label them. Select data, so that first series, its name, I could put it in a cell, but this is prob greater than 2,000. That's the forecast level. Probability the forecast level is greater than 2,000. And then this is just the prob that it's less than 2,000. And with that, I should put these values in there. That's the demand. So we should label these as well. But what we're seeing is that as the average daily demand, the upper limit on the average daily demand increases, the probability that you're going to have a greater than 2,000 recommended forecast level increases. And you can kind of see the direction that this is probably going. So that if we change these values, they should also change. So if I change this to 600 and 700, so we can kind of anticipate that, gosh, it looks like maybe around 1,200 or 1,400, or what's going to happen at 1,500. At 1,500, there's almost a 50-50 chance that you need a forecast level greater than 2,000. Of course, the minimum is still 200. So that's how you work with these simulations and distributions and probabilities and creating data tables, and they all work together to give you a good sense of what's going on.